Hey guys, so today we're going to be talking about atoms, elements, compounds, mixtures and particles. But first of all, we're going to explain what everything does, starting with atom. I'm going to be using child-friendly analogies to help you remember what each component is. Let's break it down. Let's imagine an atom is a single Lego brick. It's the tiniest part of everything around you, and you couldn't break it further down. For example, with a Lego brick, obviously you can, but just think of it as the smallest thing. You can't break it down any further than it actually is. And I've used a Lego piece to describe how it's the building block of everything. You may hear that term because it's the smallest thing that you can use multiple of to build onto new things. So to summarise that, I'll write my notes down here. It's the tiniest part of everything. So I've written my notes and I'm just going to highlight everything that I think will help you so colour can help you use your imagination. So remember, it's the tiniest part of everything and it's just a part, okay? You cannot break it down without changing what it is, and it's the building block for everything. So now I'm going to be using an example to just help you. So if we think of the hydrogen atom, remember an atom is the tiniest part of everything. You cannot break it down without changing what it is, and it's the building block for everything. Let's think of then hydrogen as a single building block of Lego, just one. It's the smallest piece in water, H2O, and it cannot be broken down into anything further without changing what it is. Hydrogen is the simplest thing, you cannot break it down. So that's an example for you. Okay, and to just summarise this all up for atoms. Atoms are the most basic building block of everything in life, from the air we breathe or to the chair we sit on. It's the most basic bit of matter. Okay, let's just number that number 1. Okay, now we're going to move on to number 2, elements. So let's just remember quickly because I just forgot. Atoms are the most simplest things. I know we've covered that, but that means if we're applying it to a Lego, let's say this Lego is red. Okay, and let's apply it to hydrogen, which is an atom. So therefore, we can think of hydrogen as red Lego bricks. But however, oxygen, a simple atom, would therefore, I don't think you would consider oxygen as an atom, but you get what I mean. Let's say another atom, for example, could be blue, but it's going to be a specific colour to that specific atom. It's not the same. That's something to remember because when we move on to elements, we're going to be focusing on that. Oxygen is an atom, so we can think of them like blue bricks, one type of them. However, an element is like a whole box of these Lego pieces, and they'll be all the same size, the same colour, because they come from one specific atom. Okay, as we can see. So referring back to the analogy, okay, an element could be composed of all red bricks, which is the same as all hydrogen atoms. They're just, elements are the same type of atom, but more than one of them. So only one type of atom, for example, they would all be hydrogens, or red, or oxygens, or blue. So again, if we look at an example, oxygen is an element. It's made up of only oxygen atoms, just like if you had a whole load of blue bricks. So let's now summarise elements. They are pure substances made of only one type of atom. And also remember, the periodic table has all the list of elements with their different properties. Let's now move on to number 3, molecules. Okay, a molecule is a group of Lego bricks, but they're stuck together in a different way. So you can see how these are arranged in rows and columns. Well, you can think of them as something like this. They're arranged very differently, and they're arranged in a specific way to create something different or something new. They can be made of the same type of atom or different types of atoms. But again, atoms are still small, and they are the simplest building blocks of a substance. So for example, if we just look at oxygen again, but oxygen now is a molecule. It's made of 2 oxygen atoms. Remember, we're looking at that. 2 oxygen atoms. It's just like the same as 2 blue Legos that are stuck together. They are stuck together to make a new structure. But they're still oxygen atoms. They're still oxygen. But now it's a molecule instead of one single atom. Okay, now let's summarize molecules. Molecules can be made of the same or different types of atoms. Okay, now we're going to look at number 4, which is compounds. A compound is a special structure. It's made of joining different coloured Lego bricks. For example, we have the shaded, non-shaded, shaded, non-shaded. They're different colours or shades. It's a kind of molecule but always has at least 2 different atoms. Remember molecules? Remember what they were? Molecules are made up of the same or different type of atoms, but they're made up of atoms. But again, it has at least 2 different types of different atoms. And they're joined together to form a sort of pattern, as we can see here. Not accurate, but sort of. For example, H2O, which is water, is a compound, and this is because it's made of 2 hydrogen atoms and 1 oxygen atom. So we can think of that as 2 red bricks being the 2 hydrogen atoms, just think of that, and then 1 oxygen atom being the blue brick. So we'll just colour in the reds and leave the blue. And they're stuck together. And it's not just oxygen and hydrogen anymore, it's a brand new thing. So that's a compound. Okay, now number 5, mixtures. Okay, so let's look at the name mixtures. Okay, remember mixtures, okay? So a mixture it's like a big pile of different Lego bricks thrown together, but they're not stuck together. So for example, we could have a coloured brick here and a non-coloured brick here, okay? But you can see how the other ones are so close, but these ones are not. They're just not together. With mixtures, you can separate them. So what I like to do is just think of it as a bowl, okay? So we've got Skittles, I like to use Skittles, and M&Ms. So that's Skittles, S for Skittles, M for M&Ms, and then lots of them. Okay, you can see how these ones are so closely attached, we could not call this a mixture, okay? But what we could call a mixture is a Skittle here, an M&M here, a Skittle here. Do you see what I mean? Obviously you can see they're quite close, but let's just think of it as they're not that close, right? They're free-flowing, they're not properly combined, okay? They're mixed, but you can easily separate them. So what I mean by this is I could pick out an M&M and have Skittles on its own, or pick out 2 Skittles and leave an M&M on its own. I can separate them easily. For example, air is a mixture. Air consists of nitrogen, oxygen, carbon dioxide, and so much more. But you breathe each separately, they're not mixed together. Also, one key note is mixtures can be separated using physical methods like evaporation or crystallization or filtration. Filtration is a common one. Last but not least, we're going to look at particles really quickly. Particle is just a general word for a tiny piece of matter. So whether it's an atom or a molecule or dust, you can think of it as a tiny bit of matter, so it's a particle. Atoms, molecules, and even dust can be called particles. Even though dust is bigger than an atom, you can still see it clearly without using a microscope, so it's a particle. Okay, that's the end. I'll send out or make some flashcards and questions for you. Bye guys.